Hello students, welcome to Educate. Today we are going to study uniform circular motion. So here we are going to analyze various factors. Suppose this is circular path, this is radius r, and suppose this is angle theta. So displacement is angular, so it is theta. So if we apply arc L upon R equal to theta, and we take theta in terms of the radian, then we get L equal to R theta. So arc length equal to radius into angle. If we differentiate it with respect to t, dl upon dt, r is fixed, r d theta by dt. dl upon dt is linear velocity, so v equal to r, and this is d theta by dt is angular velocity. So we have got this relation v equal to r omega. If we further differentiate, so we get dv upon dt, which is equal to r d omega by dt. dv upon dt is linear acceleration denoted as a, r is radius, and d omega by dt is angular acceleration denoted as alpha. So we have got the relations. First relation is L equal to r theta, second relation is v equal to r omega, and third relation is a equal to r alpha. So these are the relations that we are going to make use. Also, time period, time taken to complete one rotation, and if we define frequency 1 upon time period, unit is hertz. So here various definitions are given that you can read. Omega is one complete revolution we are talking. So angle moved in one complete revolution is equal to 2 pi radian, and time taken is capital T. So here omega and 1 upon time equal to frequency, either you write f or nu. So you can say omega is 2 pi and nu, where nu is frequency. So this relation. And time period, I told you, angular acceleration, angular velocity divided by time. So alpha, that is alpha will be equal to d omega by dt, and then we put units. So it will be radian per second square if you write the unit. Frequency, its unit is hertz. Then here one relation, same thing as I told you. If this is arc, this is radius, this is angle moved, so angle equal to arc upon radius, that is here delta s is arc equal to r times delta theta. We divide both sides by delta t, so delta s by delta t equal to r d theta by r delta theta by delta t. Generally when we take time small, then delta is written as d. So we can also write ds by dt equal to r d theta by dt. And I told you that ds upon dt is linear velocity and d theta by dt is angular velocity. So this is how we get v equal to r omega in a vector form. So in vector form, it is given by v vector is equal to omega vector cross r vector. It means it is cross product, not the dot product, because this is a vector quantity. Dot product of two vectors gives a scalar quantity, whereas cross product gives a vector quantity. Since velocity is vector, so here cross product must be done we will do some numericals on the basis of these things, so you will understand clearly. Same thing is written here, linear velocity equal to radius into angular velocity. Then again, we write it and we differentiate it. So dv upon dt, r is constant, so we don't differentiate. D omega by dt, as I told you. So dv upon dt is linear acceleration, r is radius constant, and d omega by dt becomes alpha. So we have got the relation linear acceleration is radius times angular acceleration. If we want to write it in vector form, then vector A is equal to alpha cross r. Now centripetal acceleration. So centripetal acceleration means what? If object moves in circular path, so there will be one force towards the center, that is centripetal force. Centripetal force. And it is given by mv square divided by r, where v is angular velocity with which object is going in circular path, m is mass of object. So here same thing we are going to derive. So it is given by mv square upon r. Let's see its derivation. So to derive it, we have to consider the position of particles at 2 time intervals. Imagine that particle is at point P whose velocity is directed like this, and since velocity is changing its direction, though its magnitude is same, but as far as vector is concerned, so definitely we will take its direction also, so both will be different. Now corresponding to this velocity, here I have drawn AB vector which is representing V1, and corresponding to this point velocity is in this direction, so that velocity is represented like AC. And here if you see, this angle is delta theta, the same thing is shown here, this is delta theta. Now we take the resultant velocity, so here delta V is the resultant velocity, which will be equal to V2 minus V1. Other things, if you observe here, this is delta S is linear displacement, this radius same. Here we are going to compare these two triangles. So here we will make a comparison between this OQP and ABC, and we will write the ratio and then we will derive the result. So let's see how. So from the figure it is clear that, as I told you, V1 plus V2, either these two are in this direction, this is closing vector. If you remember that if one vector is in this direction and if one vector is in this direction, another vector is in this direction, the resultant will be the closing one. Here this is in this direction, then this is going in this direction, so this must be the resultant. So you can say V2 equal to V1 plus delta V, or V2 minus V1, that thing, delta V equal to V2 minus V1. Now if we take their modulus values, so delta V1 is same as delta V2 because velocity in magnitude does not change, only its direction is changing. So we use similarity concept here, delta V1 modulus equal to delta V2 modulus equal to V. In similar triangles OPQ in this triangle and in this triangle. So here this is radius, this is radius, so these two sides are equal. Similarly modulus of this and modulus of this is equal. So here the same thing, comparison is made PQ, this portion and this portion BC. So I'm writing it here so that you can easily understand. So the two triangles, as you have seen, one this, in which this is V1, this is V2, and this is delta V, and here situation is this is R, this is this is R, this is R, this center is O, and then this point is P, this portion, this is delta S, and this is say Q. Here ABC, this is ABC. So here our concern is these two sides are equal, this OP equal to this OQ, here this AB equal to AC. So that thing is written here, and then this will correspond to PQ. So the same thing is written here. If you observe, I'm showing it with the same diagram so that it will become clearer. Here comparison is made. The ratio of these two, they are equal. So ratio of these two means AB is to AC is 1. Here OP is to RQ is 1. Angle is same. So SAS similarity will give that triangle, both triangles are similar. If they are similar, then the ratio of the sides will be same. So we can also say that this PQ will have same ratio as that of BC. So same thing is compared here in this diagram. So PQ upon BC equal to OP upon AB, and then PQ is that displacement, this portion in this figure, this portion. So PQ upon BC, so delta S divided by corresponding portion in that AB in this figure, this delta V portion. So sorry, delta S upon delta V equal to R upon corresponding values of, this is radius, here this is velocity, so R upon V, or delta S upon R, we interchange delta V upon V, or delta V. So V and delta S will go together. Now what we can do, we can divide both sides with with delta T. So if we divide both sides by delta T, what do we get? So delta V upon delta T equal to V upon R will remain as it is, delta S upon delta T. If you remember delta V upon delta T, if time is small, then delta can be written as D. So we will get dV upon dt. This is ds upon dt. dV upon dt means acceleration, linear acceleration, and ds upon dt is just velocity. So we have got the result as A equal to V square upon R. So that is required expression. Now if speed is changing, so in this case, in circular motion, we consider two types of acceleration. One is towards centripetal, so AC, that is V square upon R, because if you remember, FC, centripetal force, is mv square upon R. So AC will be V square upon R. And another acceleration is in this direction, that is tangential acceleration, and that will be dV upon dt. So you can say these two accelerations are mutually perpendicular. So resulting acceleration will be like this in this direction, and it will be given by A resultant will be equal to AC square plus AT square. Now let's see one example. Calculate the linear acceleration of a particle moving in a circle of radius 0.4 meter at the instant when its angular velocity is 2 radian per second and its angular acceleration is given as 5 radian per second. So here angular acceleration, as I told you, there are two types of acceleration. Here one is AC and other is AT. In our question, what is given? Whatever information is given, that we can make use, that R is given, R equal to 0.4 meter, and its angular velocity omega is given as 2 radian per second. Angular acceleration is also given, means alpha is given 5 radian per second square. So our concern is to get total acceleration. So first we will evaluate tangential acceleration. What is that? Is also r alpha. If you remember, I derived it a equal to r alpha. So we can put the values. R is given in our question 0.4. Alpha is also given. Alpha is given as 5 radian per second square. So we can put the two values. So AT is equal to 0.4 times 5. So it will give 2 radian, but here we are deriving linear, so it can't be radian, meter per second square. So we have got the value of AT, and we have to get the value of AC. AC is, V square upon R, but V equal to R omega. So R omega whole square upon R, that is R square omega square upon R, that gives R times omega square. So we can put the value of R and omega. So here R is given 0.4 and omega square of this. So this will give, total value will give 1.6 meter per second square. So we have got two values, AC and AT, and we know the relation A equal to AT square plus AC square. So we can evaluate it. And suppose we want to find out angle. So we can find the ratio, as I have shown you, that one is AC, another is AT. Resultant acceleration will be like this, A resultant. So suppose this angle is theta. So you can find tan theta or whichever angle you want to. If you take this angle theta, then perpendicular upon base. So you will write tan theta. What would be tan theta then? If this is in this direction, it will be 80. Here, in this direction, it will be AC. In this direction, it will be 80. Right? So resultant will be in this direction. Correct? Now, suppose you want to find out angle. This is resultant, A resultant, that resultant makes with 80. Suppose you want to find out this angle. In that case, this will be considered to be perpendicular and this will be considered to be base. So you can say tan theta is equal to AC upon 80, and then you can put the relations. Okay. Here, the angular velocity of a particle moving along a circle of radius 50 centimeters is increased in 5 minutes from 100 revolution per minute to 400 revolution per minute. Find angular acceleration and linear acceleration. So question is simple, you can easily do. You are given frequency, that is 100 revolution per minute. So we can convert it into per second. So 100 divided by 60 revolution per second. So we have got new one from here, and 400 revolution per minute. So 400 divided by 60 revolution per second. So we have got new 2 and new 1. And if you remember, alpha is omega 2 minus omega 1 divided by delta t, time difference. Omega is 2 pi nu 2 minus 2 pi nu 1 divided by delta t. So we can put the values. 2 pi nu 2, the frequencies nu 2 is this, and minus 2 pi nu 1, and time taken is given in 5 minutes, means 60 seconds. So we can get the value of alpha. Then we need linear acceleration. So A equal to R alpha. In our question, radius is given. You can put the value of radius and you multiply by this value because radius is 50 centimeter. So you can put this as centimeter and you will get this value. I think you have understood. Now, next question is, a particle moves in a circle of radius 0.2 meter with a linear speed of 10 meter per second. Calculate the angular velocity. So you can use V equal to R omega. So here we have to evaluate V. R is given and here linear speed is given. Linear speed means V is given and you have to find omega. So omega equal to V upon R. Put the values, you will get the answer. Next question is, a particle moves in a circle of radius 0.2 meter at a speed that changes uniformly. If in 2 second time its speed changes from 5 meter to 6 meter per second, then what is angular acceleration? So here, what is our purpose? We have to find alpha, which is omega 2 minus omega 1 divided by time taken, and V equal to R omega. So omega equal to V upon R. In first case, omega 1 velocity is 5 divided by radius 0.2, and then we need omega 2. So velocity is 6 divided by radius is 0.2. So we have got the values of omega 1 and omega 2 and time is given 2 seconds. We put that value here to get the answer. Let's see next question. Calculate linear acceleration if a particle moves in a circular path of radius 10 centimeter with uniform speed, completing the circle in 4 seconds. Here, we have to find out linear acceleration. So, what is the relation? A equal to R alpha. And what is alpha here? We can also say A equal to, if we take V square upon R, then what do we get? Shall we get centripetal acceleration? Let's try. First of all, here information given is time is 4 seconds and radius is given R equal to 10 centimeter. Circular path, omega equal to 2 pi upon time period. So here we can get omega. So what is omega? Omega will be 2 pi divided by time period is how much? Circle in 4 seconds. So we write here 4. That is pi by 2. Now further. So what we can do? We write A equal to V square upon R and V equal to R omega. So R omega 2 pi by T whole square divided by R. So it becomes R square into 2 pi divided by T square. So what will it become? Here R is also there. So what R will be? R into 2 into pi square divided by, in denominator, time square we left. So R is given as 10 cm and it is 2 into pi square and divided by time square. Time is 4. 4 into 4. Let's simplify. 2 times. So this will become 2.5 pi square and centimeter per second square. So question is simple. I was taking time to solve this question because I want you should apply your brain. I can solve it directly, but it is necessary to give you some time to think. Now, consider next question. Question is simple. A particle moving in a circular path of radius 20 centimeter. So here R is given in our question, V is given, and you have to find out AR and AT. Do you remember what is AR? AR means centripetal acceleration, that is AC. Radial towards center is radial. So this is AR or AC. So it is V square upon R. So you can easily evaluate from here. V is given, time is given. So it will become 6. So 6 square divided by R. What is radius? 20 centimeter. So 0.2. This is 20 centimeters, 0.2 meter. So this will become 36 divided by 2 into 10. This 5. So it will become 180 meter per second square. And you need tangential acceleration also. So what is AT? AT is dV upon dt. So here V is given as 2t. So d upon dt of 2t, it will become 2 meter per second square. Now suppose you want to find out what is resultant acceleration. In that case, what will you do? So I told you that A resultant, capital R, is equal to A small r square. Capital R is resultant. So to avoid confusion, it is necessary to write here AC instead of AR. And this is AT and this is resultant. Then you can write small r here. But if you are using small r here as subscript, in that case you can take resultant as A capital R. So here our concern is to get A capital R. This A capital R. So AR square or AC square plus AT square. And you have the values of AR or AC and also AT. So you can put these values here, square them and add, and then find out square root. You will get resultant acceleration. I think you have understood. Thank you, Team Educate.